Okay, unit vectors using scalars. I touched on it a little in the other one, but I don't think it was clear enough. So we're going to go through this again. Question 11 tells you to just draw your own vector x and give it a magnitude and a direction, okay? So, question 11, we're going to draw a vector x, let's say. So here is our vector x, and our vector x, we're going to say it has a magnitude of 9, okay? So this has a magnitude of 9. And then tells us it wants to create a unit vector of this using a scalar, okay? And what that means...
Can Katharina of Virtulis come to the main office, please? Katharina of Virtulis?
That'll get recorded. What that means is, first of all, we need to change this into a unit vector. A unit vector has what magnitude? 1. Okay? So, in other words, in terms of a scale, it's going to look something like this, our new unit vector. Okay? It's not perfect, but that's the idea of it. The idea of it is a smaller version of our original vector. Okay? So, we know the magnitude of this one is going to be 1, and we know it's going to have the same direction because we're talking about the same vector, but just the unit value of it. So, it's definitely going to be vector x, but it needs to be of some scalar. Okay? It needs to be what? Anyone know how I can turn 9 into 1? I divide it by 9, right? So we know that 9 divided by 9 is equal to 1. Well, instead of dividing by 9, the idea could also be multiplying by 1 over 9. Or, in this case, okay, I want you to think about this now. This was the formula we used. The formula was we do 1 over the absolute value of the vector, or the magnitude, multiplied by the original vector. Our original vector is magnitude 9, or this vector here. And remember, vectors deal with direction. Okay, that's why we keep vector x, and we don't just give it a value of a number, because it has a specific direction, so we can't just represent it with one number. A scalar can be represented as one number because it has no direction to it. But because this vector, and we're even going to give its direction right now, north 45 degrees of east, we'll say, okay? So that has direction to it. So I don't get rid of this letter here, or that x vector, because it has direction. But I do know now that this, having the exact same direction, we're making it a unit vector, its absolute value of it, or the magnitude, is 9. So in other words, it's a 9th of the size. So this now becomes 1 over 9 vector x, which is this formula here in terms of making a unit vector. The absolute value was 9, so we had 1 over 9 and vector x. So we're just making a scale of the unit vector. It's possible to have a vector that's smaller than 1, and we'll have to even make it larger. Okay? That idea, let's try that one, example 2. Let's say we had a vector of this vector, we'll call it again, we'll call this vector y. This vector has a magnitude of 0.025, and we want to make it a unit vector. Okay. Well, in order to make this a unit vector, we have to follow our rule of 1 over the absolute value of vector x times vector x, but in this case it's vector y, right? Well, the absolute value of this is 0.25, okay? So that's 1 over 0.25 times vector y in this case, which means it's going to give us a vector. Anyone know what 1 divided by, that's 0.25. 1 divided by 0.25, anyone know what it is? 4. This scalar, this vector needs to become 4 times the size of it to have a magnitude of 4, which makes perfect sense since it's only a quarter in length, right? So now this is 4y in terms of its length. It's 4 times the original vector with the same direction, but its magnitude TUD, is that right? Magnitude, yeah, magnitude is equal to 1. So that's how we make a unit vector using scalars. And that's what that original question we did before was. It's just a little more complex than that, that's all.